Okay, so in this example, we're being asked to verify the identity, and we're going to have to use a double angle formula for cosine, right? So we've done an example like this in the past, so this will be example 2. Now, before we start this video, just be made aware that there are 3 different variations for the double angle formula for cosine, and you want to be familiar with those 3 different variations. Again, there are 3 different variations because we're able to achieve this by using the Pythagorean identity. Alright, so again, there are 3 different variations when dealing with the double angle formula for cosine. Right, so in the first example, we were using a different variation. In this example, we're now using another variation, right? So just be familiar with those 3 different variations. Okay, and then let's get right into this video. So again, when you're doing these identity problems, you only want to manipulate one side. So if I choose to manipulate the left side, I do not want to touch the right side, right? You want to leave it as is. Remember, the goal is to get one side to equal the other, right? So once you start moving around one side, don't change the other side, okay? So I'm going to work on the left side here and see what I can do. So if I look at my denominator, right, this looks very familiar. If I look at my double angle formula for cosine, I can pretty much match that up. All I have to do is add 1 on both sides, right? If I do that, I get the following, right? I'm going to get 1 plus cosine 2 theta is equal to 2 cosine squared theta, right? So all I did was I added 1 over to the left side, and you can see now that, well, that matches up with what I have right here. So I can replace this with 2 cosine squared theta, right? So I'm going to rewrite this. I have 2 sine squared theta all over 2 cosine squared theta. And you may notice that, well, the 2's cancel, all right? And this problem is almost done, right? All you have to do is break it apart. So if I break this apart, I have sine squared theta, right? And then I have 1 over cosine squared theta, okay? So think about it. I have sine squared theta. Think about sine, how we can rewrite that. We can rewrite that as 1 over cosecant, right? So if I have sine squared theta and I want to rewrite it, I can rewrite it as 1 over cosecant squared theta, right? So when I do that, I get the following. I get 1 over cosecant squared theta, right? That is sine squared theta, just rewriting it. And then I have 1 over cosine squared theta, okay? And you can see that is exactly what we have, right? If I were to multiply this out, I get the following. I get 1 over cosecant squared theta, and then cosine squared theta, okay? And there it is. So you can see that, yes, we just proved out the identity, right? They are, in fact, equal, all right? So again, that is another variation of the double angle formula for cosine. And again, we just proved out the identity. All right, and that is it.